So today in class we are going to solve quadratic equations with square roots. So if you notice here, we have ax squared plus bx plus c equals some unknown y. But on every single one of these, the b term is missing. So there's a k squared or an x squared or an a squared, but there's no a term, or there's no extra part here. So we can solve every single one of these using basic algebra skills and taking a square root. So we're going to look at number 2 first. So we have something squared is equal to 16. So I'm going to do the opposite of squaring. So we have opposites to solve equations, like multiplication and division are opposite, adding and subtracting are opposite, square rooting and squaring are opposites of each other. So I'm going to take the square root of each side of the equation, which means the k falls out, and the square root of 16 is 4. But we're not done right there. We have to think about the fact that this is a parabola, and it's going to intersect the x-axis in two locations. And we can also think about this as something is being squared is equal to 16. Well, there's two things that work there. We can put 4, or we could also put negative 4, because when you square a negative, it becomes positive. So every answer, when you take the square root at the end, you're going to add a plus or minus here. So we need two answers for every single one of these problems. All right. The next one we're going to do is number 3. So we're going to take the square root of each side right away. So we get x equals plus or minus the square root of 21. Now the last problem, I was able to take the square root of 16 because it is a perfect square, but I cannot take the square root of 21. So I'm going to come up with the old, I'm going to get the old calculator out here, and the square root button is above the x squared. So I hit second square root and then put 21 in. I'm going to round to 3 decimal places, 4.583. So x is equal to plus or minus square root of 4, no square root, plus or minus 4.583. I already took the square root, I don't need the square root again. All right, so either one of those, that's the exact answer, that's a decimal approximation. Okay, the next one I'm going to go over is number 6. So here I have to get the n squared by itself before I take the square root. So I'm going to divide by 2, and n squared is equal to negative 72. Take the square root of each side. Oops, there's a problem there. I can't take the square root of a negative number. So this one has an answer of no solution, which always makes every algebra student upset because they want to have an answer. It's like, I did the work, I want an answer. Gosh darn it. Number 9 is next. So we have subtract 7 on each side of the equation, and we get m squared is equal to 81. And we're going to take the square root of each side of the equation, square root, and m is equal to, that's a perfect square, plus or minus 9. So if you put 9 back in here, or negative 9 back in the original equation, you get the correct solution. Number 12, just because it has a negative doesn't mean that it's no solution, because I'm going to divide each side by negative 2. And I get k squared is equal to negative divided by negative 1, or negative 2 is 81. Now we're back to the last problem. Take the square root of each side, and k is equal to plus or minus 9. Okay, let's do one that has more steps than the front page here. Let's look at number 18. Number 18 is actually 3 steps, because you're going to move the 2, you're going to take care of the 10, and then you're going to take care of the square root, or the square. And so basically you're kind of working through the order of operations backwards when you solve equations. So we're going to take care of the 2. So we're going to subtract the 2 over. So 10n squared is equal to 290. We're going to take care of the 10. There's multiplication in them thar hills, so we're going to divide by 10. So n squared is equal to 29. Now here's one that's not going to come up with the an answer, it's going to be a decimal because 29 is odd, it's prime, and there's just no square root to it that's an exact number. So I can come up with a decimal approximation. Why am I wanting to write square roots again? Let me clear that out. Alright, so square root of 29 on the calculator, second square root, and 29, and boom, 5.385. Go team. They can look more complicated than this, but the general idea here is just you're solving it like for x, like a two-step equation, but then at the end you have to take a square root. So again, you can also write this square root plus or minus 29. So either answer is acceptable, the decimal approximation or the exact answer. Number 28 is going to be weird for you looking at that because it's not the same order, like it has the variable first, number second, but still we're going to take care of the number first. We use the sign in front of the 3, so it's a positive 3, so I'm going to subtract 3 over. The negative drops straight down, and I have negative 85. You lose 3 more dollars, you've lost 85, you lose 3 more, so you've lost 88. Divide by negative 4, and x squared is equal to 22. Alright, square root. So x is equal to plus or minus the square root of 22, and again, that doesn't work out to a perfect square, so I'm going to a weird decimal answer. Well, not weird, it's just the square root of 22. So I go to the calculator, I hit second square root and 22, and I get 4.690. So 22 is not a perfect square, but I get this decimal answer here at the end. So your perfect squares, remember, are 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 4 times 4, so 16, 25, 36. They're on your yellow paper, of course. 49, 64, 81, and 100. And those are all the perfect squares up to 100. And those are the ones that are probably you're gonna see the most. So those are your perfect squares. So we didn't see any perfect squares on this side of the paper, but we saw 81 twice, and we can take the square root of it, easy. We saw 16. This one here is going to be a perfect square one, so we can divide the negative 5 over, and we get x squared is equal to 100. And then you take the square root of each side. Square root of 100, of course, is 10, so plus or minus 10. All right. So have fun with these. These are the beginning of solving quadratic equations, and there's no single linear term. The linear term is missing. The quadratic term is there. There's a number, but there's no linear term. There's no x to the first power, or k to the first power, or a to the first power, or m to the first power. It's just doing basic algebra steps and taking a square root at the end. And sometimes you get a whole number, and sometimes you don't.